Mawsynram, a town in northeastern India, receives 11,000 millimeters of rainfall a year. That is 11 meters of water, making it the wettest place on Earth. Yet to the west lies the Thar Desert, a hyper-arid landscape where water is so scarce it dictates every aspect of survival. Curious, these environments exist within the same borders at the exact same time of year. One region faces record-breaking floods, while another, hundreds of miles away, remains bone dry. These variations aren't accidental. This range of environments is the result of invisible atmospheric forces operating high above the ground level. To understand these forces, we first have to map the extremes. High in the north, the peaks of Ladakh sit in a freezing alpine zone. This happens because of the normal lapse rate. As altitude increases, air density and pressure drop, causing the temperature to fall by about 6 degrees Celsius for every 1,000 meters of ascent. Drop back to sea level and head west into Rajasthan and Gujarat, and the environment turns into a scorching, scrub-filled basin. Then, along the southern coast, the Western Ghats create a lush, tropical environment packed with moisture. Geography sets the stage, but the true architect connecting these disparate zones is a massive system of moving air. To see how that air moves, we need a vertical view of the atmosphere, looking at the land and the ocean side by side. When exposed to the same solar radiation, dirt and rock heat up much faster than water. As the land heats the air above it, that air expands and rises. This leaves behind a partial vacuum at the surface, an area of low pressure. Out over the ocean, the water takes longer to warm up. The air above it remains cooler and denser, pressing down to create a high-pressure zone. Because the atmosphere naturally seeks balance, air flows from high-pressure zones to low-pressure zones to fill the void. This basic physical difference in temperature creates a pressure vacuum powerful enough to move the weather for over 1 billion people. In the summer, the vast Asian landmass bakes under the sun, creating a massive continental low-pressure system. That vacuum draws in moisture-laden air from the Indian Ocean. These are the southwest monsoon winds. When these heavy, wet winds hit physical barriers like the towering Western Ghats, the air is forced upward. As the air rises, it cools rapidly, causing the moisture to condense and fall as heavy rain on the windward side of the mountains. This seasonal influx of moisture is the primary engine that feeds India's tropical zones and sustains national agriculture. By winter, the process runs in reverse. The landmass cools down quickly, while the ocean holds onto its heat, flipping the pressure zones. Now, dry winds blow from the high-pressure land back toward the sea. This is the northeast monsoon. This cyclical continental breathing is the ultimate balancing act of the subcontinent's climate. Zooming in from the continental scale, we can see how this system is being altered at the level of the metropolis. In cities, a phenomenon known as the urban heat island is creating localized disruptions. Dense concrete and glass trap solar heat, while a lack of vegetation prevents natural cooling. This creates pockets of high temperature that can be significantly warmer than the surrounding countryside. By concentrating these heat-trapping materials, human development is now altering localized climate patterns. For the Indian farmer, these shifts in the broader atmospheric system are a matter of survival. A weak monsoon season, caused by a failure in the pressure system, leads to drought and crop failure. Conversely, an overly intense monsoon brings floods that can displace entire communities. Monitoring these shifts in pressure and wind is a necessity, the foundation of India's economic and environmental stability in a changing world.